Hi everyone, this is Tamu. Welcome to my channel, The Cloud Security Guy. In case you are new here, I talk on a weekly basis about things like cloud security, artificial intelligence, and general cybersecurity career advice. Today it's like a bit of a special video. This is based on a lot of feedback and requests I've gotten on my channel about cloud security and what viewers want to see. So, what am I talking about here? So, what's the topic for today's video? So today's video is based on basically a complete course, a mini course on cloud security. I call it Cloud Security 101, and I'm going to be talking about all the fundamental topics about cloud and cloud security. So after this small mini course, you should understand cloud security in and out, and you should be in a very good position to move ahead with a career in cloud security. So just to give a background, cloud has been like exploding, like in 2023 end user spending is expected to reach around 600 billion, which is like a massive number. But at the same time, cloud security can be very overwhelming for newcomers, even for experienced cybersecurity professionals who are looking at cloud for the very first time. This can become a very complicated topic. A lot of people have reached out to me to explain cloud security from scratch, right from the very fundamentals and without too much technical jargon. So this is the reason I thought about making this video. And it's not even a video, like you can think of it as a mini course. I call it Cloud Security 101. So if you understand what 101 usually means, it means like a very basic beginner's course. My purpose is to explain the concept of cloud from scratch. What are the different models, deployment modes, and what are the key security areas? So if you have never heard of cloud before, then this is the video for you, okay? I'm going to summarize all of the key concepts in this video. So you should have a firm understanding of the cloud. What are the cloud security concepts? What are the different deployment models? What are the cloud security areas you should be focusing on? And if you're starting in cloud security, then definitely this is a video I should recommend for you. It's like I said, this is like a mini course, a completely free mini course, which is going to explain everything from scratch and set down the foundation for you. Before we move ahead, guys, please do like and subscribe to this channel so that you are informed about new videos as and when I upload them. It will really help to please like, subscribe, comment, share as much as you can. Thank you. Okay, so let's get started, right? Let's take a step back. Now, the last couple of years have been very crazy if you're in the cloud industry like I am. I mean, we had the global pandemic and we had like a lot of economic concerns, but cloud adoption was accelerated across the world as companies realized that, hold on, keeping everything in our data centers is not the best idea, You might have heard the words digital transformation and cloud migration being used regularly across the companies over the recent years. And for people not familiar with cloud, this was a very challenging. A lot of terms were being used, hence the reason I've made this video. So like I said, I'm going to be teaching all the fundamental concepts of the cloud from scratch in this mini course. And another benefit, if you are preparing for the CCSP or the CCSK, then this course will help you with the fundamental concepts. And I'll clarify a lot of the areas which are covered in that exam also. So those topics which I'm talking about, they get covered in the exam also. So this is not a CCSK or CCSP preparation course, but the concepts I'm talking about, they are the same. Okay, so let's get started, guys. Let's get with the very first module of this course, which is what is cloud computing, right from the very start. To understand cloud security, you need to have a very good, firm understanding of what are the different types of cloud characteristics, the cloud models, the cloud modes. So let's start everything from scratch. So to appreciate cloud computing, to understand it, you need to have a bit of a history lesson. Not a boring history lesson, but just how we have reached here. So historically, companies used to have like on-premise data centers, right? A data center simply meant that organization maintained all the IT infrastructure needed by the business on site. And an on-prem data center included everything from the servers, your web servers, email servers, to the networking hardware, everything, even the supporting equipment like UPS generators. Depending on the organization, this could be like a small closet, if you've seen those small closets in small companies, right? Or like a massive dedicated private data center, like those which are operated by large tech or corporations. So basically, but everything was maintained on site, everything was done like that. And what happened, of course, what happened was people started to realize that, okay, getting a server and just using it for one application might not be the best way to fully optimize it, And then technologies came up like virtualization. What is virtualization? It was basically taking a physical server and logically dividing it into multiple servers. Logically, okay, so the server remained the same, but from the user perspective, you could make like multiple small servers out of this, like a web server, like an email server. And from the user perspective, this was completely transparent. They would not understand. So what am I doing? You used to call it virtual machines. And these virtual servers, they act like unique physical device running their own operating systems. And you were basically dividing that physical server into multiple small logical servers. And from the user perspective, this was completely transparent. So this seemed great, and it was a big innovative step forward. But the thing was, it was a bit complicated, and you were still keeping these like hypervisor and these virtual servers in your own data centers, right? So you still had physical servers in your own data centers. And of course, if you've ever worked in a data center, you know it's expensive to build and manage your own data center. You need to buy new equipment for your data center. You need to hire experts who know everything about the data center. A lot of operational overhead was present. Okay. And then they after that, the concept of moving the whole data center outside the company was born, and cloud computing was born. Now, cloud computing does not mean your data is floating somewhere in the clouds or space, but simply means that you do not have to worry about hassle of maintaining data centers, network equipment, etc. All of these things get abstracted away from you. And what happens as a result? Organizations can move faster, right? You don't have to worry about purchasing and provisioning hardware. Everything is in software, and downtime gets reduced because your servers, you can increase and decrease them as you want, right? You can save money because your capital expenditure goes down, and you can plan it better. And we also see security benefits because you're moving things to a cloud service provider, and we'll see later that these cloud service providers, they follow very strict security standards to make sure that their customers' data is protected. So you actually benefit from the security perspective. So this is how cloud computing, a very high level history of how cloud computing came about. Okay. So what is the industry standard definition? What's written in the books, as they say? Cloud computing is a model for enabling ubiquitous, convenient, on-demand, blah blah blah. I can't read that, guys. I really find this very boring. You can memorize it maybe for an exam, but this gives me a headache to read. You can take a look at it later on. But what does cloud computing mean? Okay, let's take a look at it. Cloud computing simply refers to storing and accessing data, software, or programs or services over the internet or the cloud instead of in physical hard drives, servers, or mainframes. Through cloud computing, this data can be accessed from the internet connectivity through internet connectivity, regardless of wherever you are located. You can access this data. Okay, it also allows organizations the flexibility to allocate and reallocate your resources based on what the demand is. So if you have high demand, you can increase the server performance. If you have low demand, you can decrease it. And what has happened as a result, the cloud has paved the way for organizations across the industries to really undergo digital transformations. And it has been very swift. Forbes, it was reporting that by 2020, nearly 83% of enterprise workloads were in the cloud because of the pandemic and because of other factors also. So this is what happens. But this is the more accurate description of cloud and cloud computing. Basically, you're not worrying about the data, it's kept somewhere else, and you're accessing it over the internet. All those hassles of data center, physical infrastructure, and all those other things, they get abstracted away from you. And when you talk about cloud computing, a lot of things comes into mind. Cloud providers such as Amazon, Microsoft, Azure, Google, Oracle, they provide cloud computing services to users and organizations all over the world. Okay, millions of customers are trusting these companies with their cloud workloads, and it's a very common thing now. Lots of companies are jumping on this. Just a quick disclaimer: I'm working in AWS right now. I'm working in Amazon because I just wanted to let you know. I'm not gonna recommend or de-recommend anybody, but I myself, I work in Amazon Web Services in the cloud company. So these are all the cloud companies which are very popular. There are others also. Okay, so let's take a look. Now we've understood, okay, high level, what are the cloud, and like what are the, what do you call, major cloud companies. So what do you think are the major things, the characteristics of a cloud? Like what makes the cloud a cloud? Okay, what are the key characteristics? So there are certain things, certain key characteristics of cloud computing. They are divided into five as per the industry definitions. They are resource pooling, self-servicing, broad network access, rapid elasticity, and metered service. Well, what does that mean? Like, I know this is like a mouthful. All of these seems like technical mumbo jumbo. So let's go step by step and break it down. Let's start with the very first one, which is resource pooling. Resource pooling is one of the most fundamental characteristic of cloud computing. What does it mean? It simply means the cloud provider has a pool of resources a large amount of servers and storage and networking, which they allocate to their customers, right? You are not aware of it. They have like a multi-tenant. So it's not just you, right? There might be millions of other customers. But from your perspective, it's completely transparent. So you have a pool, and the portion of that is allocated to the customers, depending on what their needs are. So you have providers servicing multiple clients or customers with the resources like hard disks, like servers, like networking, and these services can be adjusted to each client's needs. And from the consumer perspective, from you, this is completely transparent. You don't know how much percentage of a physical server is being allocated to you, right? So this is what a resource pooling. So if the cloud providers have these huge amount of pools or resources which they are allocating to customers, and all of it is transparent to the user. Okay. So this is what is referred to resource pooling. What's the next one? Self-servicing. This is one of my favorite aspects. So what does it mean? Basically, you can provision the cloud resources from the using on-demand self-service, meaning you can just go to a console with a few button clicks. You can provision a server, right? You don't have to get involved with any human. You can do it yourself. So there is no more waiting for weeks or months even to provision a server. With just a few button clicks, you can have a full production server ready. So you can imagine just how easy cloud computing makes it. Okay, of course you will put in controls to make sure like it's not an insecure server, but this is one of the best things about cloud computing. You can have self-servicing come up. Okay, what else is there? Broad network access. What does that mean? Broad network access is pretty simple. It simply means that all resources are available over a network without any need for direct physical access. I mean, you're not going to the Amazon data center or the Microsoft data center and plugging in your switch, right? It's all being accessed over the internet. And because we are hosting things in the cloud, so it becomes like you just need the internet to access it. Of course, they're not going to provide the internet for you. You need to have that, but it's available over the network without any direct physical access. One thing you will have to consider, of course, if you're hosting your data in the cloud, you're storing it in someone else's data center in some other physical location, okay, not in your on-prem. Then, so you might have things like jurisdictional boundaries or data sovereignty. Say you're in Pakistan or India, and you're storing it in the United Kingdom or maybe like in the Middle East, okay. So maybe your company's laws are very strict and they don't allow that data to go out. So these are the things you need to take into account before, right? When you're choosing a cloud provider, you need to ask where that data is going to be stored. You yourself have that control, okay? But you need to get this very clearly in the agreements and all that. So you might need to put in controls to make sure that that data does not leave that particular jurisdiction. So if you're storing it in Europe, it should not leave Europe, because then you have other things like GDPR and things coming up. So these are the things you need to consider before when you talk about network access. You're storing it somewhere else and you're accessing it over the internet. Okay. What else? Rapid elasticity. So what does that mean? When you say elastic, you mean like this, like you're stretching something, right? What basically it means, at any point in time, users of cloud services, they can acquire more or fewer resources as they scale up and down, as per your business needs. Supposing it's like a Black Friday is happening, right? There's a lot of load being put on your servers. You can simply automatically increase the processing power of the server, or you can add more servers and distribute the load. Okay, you can simply upgrade, downgrade hard disk storage. You can move from one service to another without like having a big change to your IT infrastructure. Unlike on-prem, where there were a lot of things would have to be done, rapid elasticity simply means you can expand or contract your resources from the pool. Okay, you can provision, deprovision things automatically, and this can match your resource consumption. So maybe on weekends the load is more, you can increase your servers at that time, and maybe on the normal weekdays the load is medium, so you can decrease your servers at that time. So it becomes very, very efficient, right? You are creating and deprovisioning things on the fly, and this also helps to optimize your cost and everything. Okay, so and this links into the next one, which is called metered service. What is metered service? So if you've ever used like electricity or water, what happens? You get charged, right? But you only get charged for what you use, right? So metered service is cloud service. They provide enough use. They provide you what you are using, and you get charged for what you use. So basically, your users' or consumption levels, they are monitored and they're controlled, and you know what you're using. So you are only allocated what you need, and what you use, you're charged for it. So like this is where the term utility computing comes from. So computing resources, they are being consumed like electricity or water, and you're only paying what you need. Unlike on-prem, on-prem, what happens? You buy this huge storage, or you buy this huge server. Maybe you're only using 20% of it, but what are you going to do with the rest of it, right? Or maybe you buy like a huge storage device, you're only using 10% of it, or maybe after 3 years you need to replace it, right? Because that hardware is out of date. So this problem goes away in the cloud. You only get charged for what you consume and what you allocate. So this becomes very, very efficient. But however, one disclaimer I would want you to give based on many, many experiences of cloud migrations, these benefits really appear if you understand and adopt cloud native models, okay? And you adjust your architecture and you adapt them for the cloud. So you need to make sure you're using the power of the cloud and the features of the cloud. If you're just taking an application, and just copy pasting it onto the cloud, just spinning up a server and just putting that application over there, and then later on saying, how come I'm not getting all these benefits? This is not the way. In fact, copy pasting stuff and just putting it into the cloud, that can might actually increase your cost because you're not taking any benefit of what the cloud is. So this is why it's so important, guys. So please take these things into account when you're doing any cloud migrations. Take benefits of the native power of the cloud. Okay, so now we've covered the characteristics of the cloud. What are the different service models? By what do you mean by service model? Each cloud, it has offers a specific set of functionalities, cloud models, and it is really important for you to understand as a company what the differences are. So you have things like software as a service, you have platform as a service, and you have infrastructure as a service. So you need to think about what you need. Do you need like a simple software for processing your business? Maybe you need to do some data processing, or maybe you need like a platform to create applications, to generate coding, to do applications, or maybe you need complete control of your entire infrastructure without having the hassle of a data center. For each of these needs, you have a different service model. So no matter which option you choose, there is an option available for you. But remember, the cloud is the future for your business and technologies. Whatever business need you have, believe me, the cloud can accommodate it easily. So let's look at each of these one by one. Software as a service. This is easily the simplest one. If you have used the internet, you have already used software as a service, right? Ever use Gmail? Ever use YouTube? If you're listening to this on YouTube, you're already using software as a service, right? So this is the most common model. You only care about your data and accessing it, right? So it's a full application, completely hosted and managed by the provider. All you're worrying about is the access. You just access it through a web browser, a mobile app, maybe like a client app. So it's completely delivered. You don't have to worry about installing anything, or installing any hardware, any software. The SaaS vendor, it manages all the potential issues like data, storage, servers. You don't have to do anything except just provisioning the access. Okay, so it's very advantageous. You can understand, right? If you need to do something quickly, there's no hardware, there's no software, no installation, no upgrade. It frees up a lot of time for your technical staff. You can focus on more important stuff. So if you're a startup or a small company that needs to launch a product very quickly, you don't have time for server issues or software. This is very good for it. For good for short-term projects that require quick, easy, and affordable solutions. However, just be for everything. Of course, there is a. I want to tell you the con also. I'm not going to just tell you all the benefits. With the SaaS solutions, there is a lack of control, right? You lose a lot of control also because you're basically handing over control of your data to a third-party provider, right? These controls are what you call. You only have control over your access, like how you're accessing it, but the security, the maintenance, everything is like being handled by the software provider. So you need to make sure your data security and governance models are there, contracts are there, where the data is being stored. There is a lot of dependency also. With the ease that comes, a lot of dependency also moves to the service provider, the cloud one. And you need to make sure things like Dropbox, Salesforce, if you use them, you understand what it is, right? So let's move on to the other one, which is platform as a service. So the delivery model of platform as a service is very similar to SaaS, except instead of delivering software over the internet, you're getting a platform, maybe like something like software creation. Like some of these examples, you can see Google App Engine or Amazon Elastic Beanstalk. They give you a complete platform for developing web applications, whatever application you want. This platform is delivered via the web. So you give developers the full freedom to build the software without having to worry about operating systems or software updates or storage or infrastructure. It gives you a complete framework which you can build upon to create your own customized applications. Okay. And all the servers, storage, everything is managed by the third-party provider. And you as a developer, you only maintain management over the applications. So it's really good if you have like a requirement to have more control over your application and you're developing something with special software components. The platform as a service is a very good like option for you. However, What's the disadvantage here? Now, usually from what I've seen, there is like a something called vendor lock-in. Your dependency on the vendor increases. Okay, so you might have a specific platform as a service solution, and you want to change it later on. You want to move to another. Maybe from App Engine, you want to move to Amazon Beanstalk. Sometimes it's not so easy to migrate, and switching to alternate PaaS solutions might not be feasible without affecting the application. You might not also, if you're migrating an application on-prem to a cloud, right? You might not be able to do it without like customization. Sometimes it's not plug and play if you are migrating applications and you're not doing it from scratch. Okay, so these are the things you need to, and the more you customize, the more complex it can become. So these are the things that might impact the value of your platform as a service investment. So just something to keep in mind. I'm not saying this will happen to you. If you do the proper due diligence and you understand how it's happening, definitely you will get a lot of benefit from platform as a service. Okay, and lastly, what is the last one, which is infrastructure as a service? So cloud infrastructure services, it's like easily the most common one. It's made of simply you're getting those infrastructure services like compute, network, and storage, right? Fully self-service, you can access, you can provision your own servers, your networking, your storage. As a business, you can purchase all of these resources on demand instead of having to buy hardware. So infrastructure as a service, it will deliver cloud computing infrastructure, all of it through virtualization. But this time, virtualization is happening on the cloud, and you don't have to do anything. However, just keep in mind, as opposed to SaaS or PaaS, you are responsible for managing aspects such as applications, runtime, operating system patches, the uptime of the server, like making sure your servers are patched, everything. The main thing which the provider is going to do is the data center. The data center, you don't have to worry about the security of the data center, the management of the data center, all of that goes away. Okay, so it is very flexible and it's very easy to automate and all that. Just be understand that your responsibility as a customer increases, and we look at it more when we look at it from the cloud shared responsibility model, which I'll talk about in detail in the next module. But these are the like the types of things which are available in the cloud, guys. I hope you understood. So now that we have these things, let's move on to the deployment models. So regardless of what type of service model you're using, you need to understand one thing, guys, which is there are like four types of deployment models. What do I mean by deployment model? Like how the cloud service model is, how you're consuming it, the way in which you consume it. And these are, regardless of whether you're using SaaS or PaaS or IaaS, these are the one of the four you will be using, which is either public cloud, private cloud, community cloud, or hybrid cloud. So let's take a look at each of them one by one. What is a public cloud? Now, the public cloud is an infrastructure. It's open for use for the general public, or basically the large or a large industry group. It's like a multi-tenant model. So multiple users from multiple companies can use it. You can have millions and millions of companies accessing it. So the cloud service provider, it provides maintenance and ongoing management of the cloud service, right? You are just responsible for accessing it, and it's an on-demand. You can have resources dynamically allocated. Usually, all the cloud resources are at the premise of the cloud service provider. They can have like thousands of data centers across the world, right? You're accessing it over the internet, and it's ideal for pretty much any type of company, whether you're a large Fortune 500 or a small company. You can use. You have providers like AWS, where I'm working at, Microsoft Azure, Google Cloud. All of these things are there. So public cloud is probably the most well-known and the common type of thing. What's the next one, which is private cloud? Now, private cloud, unlike the public cloud, which is like multi-tenanted, a private cloud is a dedicated infrastructure. It's for a single organization, and like it's single tenant. So it is inaccessible to those outside of the company. It's operating on a, so this is public cloud, multi-tenant. Private cloud is single tenant. So only a company's employees can access the private cloud for your different operational needs. And you can still do the same things. You can allocate resources dynamically and all those other things. But this is dedicated to a single company. It may exist on the premises of the cloud provider, or it might be in your own premises, right? And you can have, usually it's used for like sensitive data applications or operations that require high level of security or control. I've seen it for healthcare organizations or government agencies, financial institutions, telecom companies. HP, if you're familiar, they have a private cloud offering. I've seen some telecom companies also offer it. So you can take a look at it. Just Google HP private cloud and it'll show you the details of how this works. Okay. So this was public and private. Let's move on. What else is there? Community cloud. What is community cloud? So I don't know if you've ever worked like lived in a community, a shared community. There's something called a community garden. So it's a single garden, but it's shared across a community, like a particular, not, it's not open to the whole world or the whole city. Just a small community is responsible for maintaining that garden. So this is what means by community cloud. It's a cloud infrastructure shared by multiple organizations. They are sharing the resources based on some common requirement, like a common regulatory requirement. So it's like I said, it's like a community garden. It's pretty new compared to public and private. Community clouds are just like pretty recent. As you know, as the pandemic came and more companies were adopting the cloud, some companies, they could not, like healthcare or government, they could not move to the public cloud, right? But at the same time, they did not want the hassle of just or the cost of a private cloud. So community clouds were the best way, because they're not as expensive as private cloud and they're not as open as public cloud. So this is where community cloud comes into the picture. It's a modified form of private cloud, but it's shared within a group of companies. Usually, I've seen it in governments. You know, the member of a government, member companies of a common government. They have something like a private cloud, and they're sharing it. And multiple industries or departments of the same government are using that community cloud. So this is how it works. So it combines the best of both worlds, and it gives you those features. Okay. Last, what it is hybrid cloud. So hybrid cloud is pretty simple. It's simply a combination of two or more cloud models. So maybe private and community, or usually private and public is the most common I've seen. So company uses it to blend their infrastructure on-prem with the cloud infrastructure. So you still get the benefits of the cloud. So maybe you have some sensitive applications. You don't want to move them to the cloud, but you can move your storage, your less sensitive storage to the cloud. Okay. So, and then you can manage you can benefit from the cost savings that come in. Okay. It gives you a lot of flexibility, and it doesn't give you don't want to put your applications into the cloud, make them public. Okay. So it's a great way. And you get the best of both worlds. So you limit the usage of the public cloud, but you get the benefit of it. And things like storage, things like file storage, and other things you can move to the cloud. So you're basically mixing your local on-prem with a private cloud or a third-party public cloud and getting the best of both worlds. However, just guys, it does become a little bit more complicated. It's more than just lifting and shifting applications onto the cloud, right? An IT department will need to configure resources to enable them to communicate. A time will be needed for your IT trained staff to train, for users to train. Of course, your applications also will need to change how they interact with the storage and other abilities. So these are the things you need to keep in mind from the pros and cons perspective. A lot of companies I've seen that before they move to the public cloud, they use some sort of a hybrid cloud. They get familiar with it, and then slowly, they start moving like this to the cloud-based model. Okay, so that finishes, you guys, our fundamental concepts about the types of clouds that are there. I hope you understood this. If you have any confusion, just put it in the comment section and I'll be happy to respond to you. So now moving on to another important thing, which is shared responsibility. This is a very important topic. This is so important, I put it in a separate module. I did not want to confuse you by linking it with the other concepts. What is shared responsibility? Simply put, shared responsibility means your responsibility for securing the cloud is shared between you and the cloud provider. A lot of companies I've seen, they make a mistake. They either go to one extreme. Either they say, okay, now security is no longer my responsibility. I don't have to do anything. Everything Amazon or Microsoft or Google will do. No, that's not correct. You still have to do a lot of stuff and you still have a responsibility. Or they can go to the other extreme. They say, no, I'm going to double check everything. I'm going to go into the Google data center or the Microsoft data center and audit them. No, they're not going to allow you to do that anyways. So they are different responsibilities. The amount of responsibility that each party owns, it depends on the type of service and how you have implemented it. So there's a lot of difference from the cloud, right? So when you implement stuff on-prem, you are entirely responsible for the security of your services. But when you use cloud, you delegate some of that security to your cloud provider, and some of that responsibility is their responsibility. So that the amount that you are responsible for and the amount the cloud provider is responsible for, it'll vary depending on the service. And we're going to see that. So, but simply put, the most simplest example I can give you for the shared responsibility model, it's like a tenant and a landlord. So supposing you are living in a rented property, you are a tenant and there's a landlord. Now the landlord is going to be responsible for some of that property, right? Maybe the general upkeep, maybe the plumbing, the other stuff. If you have a good landlord, he'll take more care of that, right? And but from a tenant perspective, your landlord is not going to come at night and lock your doors and windows, right? If something happens, you get robbed at night, you can't point to the landlord and say, hey man, you did not come and lock my door. He's going to say, no, that's not my job, that's your job. You have to secure your doors and windows, it's not my job. So this is basically the best analogy I can give of the shared responsibility model. The cloud provider is going to do a few things, and the tenant is going to do a few things. Okay, and how does that happen? So this is how, like, the best example I can give you. So these are the few of the things which you can see from the table there. These are all of the responsibilities that are there, and the blue one is your responsibility, and the other one, the gray one, is the cloud ones. Okay, so you can see responsibility changes depending on the model. For on-prem, you do everything. As you can see, everything is blued out, so you're doing. For infrastructure as a service, supposing you provision a server right on Microsoft or Amazon, so now the patching of that server, the maintenance of that server, that's your responsibility, right? It's not going to be handled by them. They are going to look at after the data center. They're going to make sure that that service is up and running for the storage and all that, but they are not going to do the patching and the vulnerability assessments and the pen testing. That's your responsibility. Similarly, as we move to the right, platform as a service, so over there, some of the things, the operating system and all that, you don't have to worry about now. Now you have to worry about the application, the data storage, the identity and access, and a lot of that is shared, right? And then similarly, if you're just running an, what do you call, if you're doing say a SaaS model, you can find, like, if you're doing, because then in the SaaS you are delegating the most responsibility to your cloud provider, and you get the most advantage from the security benefits that the provider will give you. So you can see it changes depending. It's not a static model, it's a shared responsibility. It fluctuates depending on what type of service you're using, what type of model you have, what type of deployment you've done. Okay, so what do you think is the best one out of all these? The answer is, there is no best answer. There is nothing, no yes or no. It's up to the company to choose which model works for them, what business requirements they have, what regulations they are under, and depending on that, you should choose which model. But just be aware of who is responsible for what, and what you have to do, and what are the things you have to be responsible for. Okay, guys. So this concludes the shared responsibility model. Let's move on to the next module. Okay, guys, so now with a good foundation in place, now you understand cloud computing, you understand the different models, how it works, what is the shared responsibility model. Now I hope you have a good foundation, and we can move on to cloud security and what cloud security is, how to implement it. So, for businesses that want to move to the cloud security, the security of the cloud is possibly the most important thing and the most important risk. Usually, it's the number one thing which scares them. And security threats, they become more and more sophisticated. And cloud computing, like, it's like any other technology, right? It'll be at risk if you don't have the proper controls in place. So you want to make sure you have the best in class security there. So what's the definition of cloud security? As you can read from there, it deals with the processes, policies, resources, and technologies that are involved in keeping cloud computing architectures protected from cyber security threats and risks. So, you after reading this, you might have one question. Okay, what's the big deal and what's the big difference between this and cybersecurity? It reads like the definition of cybersecurity, just with cloud computing added at the end of it. The answer would that be no. There are fundamental differences, okay, between cloud security and cybersecurity. What are they? Okay, first of all, cloud security is API driven. Cloud is nothing more than a big collection of APIs. Almost everything in the cloud is exposed via an API, and security is no different. Almost everything can be automated. Almost everything can be looked at in a form of API form, and you can like the cloud. Like I said, it's a set of API calls. Okay, so you have to take that into account. Everything is software driven. There is no physical infrastructure there. Okay. The second one, the one I went into great details explaining, the cloud security is shared between you and the provider. There are some things you absolutely have to do, and there are some things which the provider will be doing. So you have to keep that in mind. It's not like on-prem. And lastly, the cloud is fast. More than anything, one of the biggest advantages of the cloud is how fast it is. Okay, with just a few button clicks, you can provision, like, I don't know, 100 servers. Okay, with a button click, you can potentially expose like an S3 bucket, which is like a cloud folder over the internet. With just a button click, you can open up SSH port over the internet for your server. Okay, all these things you have to keep in mind, and for that you need to have auto remediation. So you don't think about it like your normal thing, like an alert will come and somebody will from your SOC team will send an email, then the team will investigate. No, you need to have automated incident response happening, and we'll see that in more detail. Okay, but these are the things, how the cloud, the speed of the cloud, how the responsibility is shared, and how it's API driven. And when you talk about implementing cloud security, whichever technology using, be it Alibaba, Oracle, Amazon, Google, Azure, how to implement it? Well, the first step would be to identify your requirements. Okay, legally, can you even use the cloud? Maybe in the country in which you are in, it has certain restrictions, and cloud computing will not be allowed. You need to find that out. What are your requirements? What are your use cases? Then, of course, you select your provider, right? What type of model are you going to be using? Is it SaaS, PaaS? Are you going to be using the public cloud, hybrid, community? Before you going on to security, you need to understand that, right? Then you need to define the architecture. How will that thing be accessed? What sort of things am I going to be using? Are you going to be using zero trust architecture? I did a full video on zero trust architecture. I'll try and link it here, but you can take a look at that when you talk about architecture. Then we're going to talk about assessing the like the security controls, right? No need to do this manually. Cloud provides you tools, and there are industry standards available, okay, which I'm going to talk about in detail in a few slides. And then you, of course, you're going to look at the gaps, right? What are the control gaps? When you judge against the standard, what are the gaps that are coming and how do I fix them? Then you, of course, it's no different from other cybersecurity, but then you implement gaps. So you fix those gaps, and then you monitor them. So I made a detailed video on this, on how to implement a cloud security roadmap. So I'm not going to go into too much detail. You can look at that video. It'll give you a full video overview of how to implement a cloud security roadmap. Okay. So moving on, when you talk about cloud security, another very, very important thing is cloud legal contracts. So you're extending your data to another party, right? How will you know? They will do as they have committed, like they've said, I'm going to do this, be security. The primary tool of governance between you and the cloud provider is the contract, right? Whether it's public cloud or private cloud. The contract is your only guarantee that the commitment which the cloud provider has made, they're going to be doing it. Otherwise, it's going to become a breach of contract, which then it becomes a legal issue, and then you can call your legal guys to make sure they enforce this. Okay, but contracts are the primary tool. You need to make sure they are vetted by legal, and your business partners and providers are looking at it. And can you, like, if you want to make sure that you can audit them, then you have to make sure that's in the contract, right? Can you look at their reports? What sort of assurances are they going to be given? What happens if there's an incident? Who's going to contact you and all that? All these things have to be in the contract. So make sure that your legal contracts are covering all your due diligence issues. What else? Compliance in the cloud. So just like with security, compliance in the cloud is a shared responsibility. So when you're talking about audits, both the cloud provider and customer have responsibilities. But the customer, like you are always ultimately responsible for your own compliance. And these are defined through in your agreements, in your contracts, especially for public cloud. For public cloud, now let's take an example of a PCI DSS audit. Okay, so your provider, they will be PCI DSS. The underlying infrastructure will be PCI DSS certified. Okay, and they will have audit reports. They will share it with you. But on top of that, if you are building services, right, and you have to, like, you're configuring a service like an S3 bucket or a server, you have to make sure that you are configuring them as per PCI requirements. Whether it's PCI DSS, SOC 1, SOC Type 2, HIPAA, whatever it is. Okay, you have to make sure that you are configuring things as per the requirements of the standard. Okay, so it's your responsibility as a customer to build compliant applications and services on top of the cloud. The provider infrastructure, usually they are not within the scope of your audit. They will just give you reports which you can share with your auditor, but what you're building on top of them. Okay, so example, you are building a server in Amazon, okay, EC2. You have to make sure that the EC2 server is hardened as per the PCI DSS requirements or whatever standard requirement you have. Amazon is not going to do it for you. Okay, they will give you the underlying infrastructure, and you can configure everything as per the standard. But just remember that you are ultimately responsible for maintaining the compliance of whatever you deploy on top of the cloud. Don't think that Microsoft or Google or Azure, they're going to make you PCI DSS certified. That's not what's going to happen. You still have to do that. They're going to do a lot of the heavy lifting for you, but the other things you have to do. So talking about standards, guys, what are the standards which are there? Well, you have things like the CIS benchmarks. They have benchmarks for Azure, AWS, Google. You have a NIST complete standard for cybersecurity. You have the ISO standard 27017. So you don't have to create your own standards from scratch. And a lot of the cloud providers, they already give you solutions which are there within the cloud. They're going to do a complete assessment and give you a report. Okay, these are the controls which are missing in your environment, and these are the things you have to configure. And after that, you will be completely, like, most of the way you'll be certified to a particular standard. So keep that in mind. These are the standards you have to be looking at if you want your cloud to be certified to best practices. Okay, so now that we have done a big overview of cloud security, let's deep dive into the cloud security areas. And for each, there are multiple areas in the cloud you have to think about when you're implementing cloud security. Honestly, there are like 5 or 6 of them, and all of them I could talk about like 2 hours for each of them. But let's get started. Let's get rolling on this and give you a foundational knowledge. And if you feel you want me to do a deep dive on any of these topics, let me know, and I'll happy to make another detailed class on this. So first of all would be identity and access management. So when you talk about the cloud, so remember on-prem you had things like firewall and you had other things which created like a security perimeter. You don't have that in the cloud. There's an old saying that in the cloud the identity is the new firewall. Okay, so when you're approaching cloud, it's very very important to secure the identity. When I talk about identity, I'm talking about your users, your services, all the identities they're using. Okay, usually users and your resources, they are the one who are using user IDs and identities in the cloud. Okay, and even services like I don't know, you're using like a database to access another function, there will almost always be some sort of a role or user there, so you have to secure them. Just remember, there's usually in the cloud there's no like in identity and permissions, they become the most important part of your security. On-prem, historically it was done through network level controls. Okay, and you had like things like firewalls and other things. Those are no longer sufficient. You need to have a very strong identity framework. The good thing is most of the public cloud providers, they give you a lot of tools to secure them. So the ones I've mentioned here, like root access security, you don't want to be using root, right? You want to create your individual users and give them permissions. You need to have like strong identity and authentication there, strong password policies. MFA is a must for your critical IDs. You need to have a single sign-on. I made a detailed video on single sign-on. I'll try and link it here. And you need to have multi-cloud. So if you're having multi-cloud, then you should have single sign-on. Because if you're using Google, you're using Azure, you're using Alibaba, you don't want to be creating multiple IDs, right? In each of these clouds, it's a nightmare and it increases the attack surface. So definitely you will get that compromise if you don't put these things in. Single sign-on is a must for a cloud, multi-cloud environment. So all of these things keep into account. Okay, what else is there? Infrastructure security. Cloud infrastructure, you want to secure your resources deployed in the cloud. And this becomes very different in the cloud as opposed to on-prem. Usually in the cloud, everything is infrastructure as code. People don't want to like manually provision servers through the console. They document everything in a Terraform template or maybe like a CloudFormation template. And the security has to be there within that template itself. You want to scan it. Okay, what if your template has an insecure server there which opens up a pathway to the internet, right? SSH port or RDP port. So all of those things you need to take into account. Misconfigurations that happen as a result of this, they are the most common reasons for cloud breaches. Not cyber criminals, simply people making mistakes in configuring the cloud. And we'll talk about it when we talk about solutions such as cloud security posture management. Apart from that, we have things like workload management. So basically your workloads which are running, your servers, your containers, you want to make sure that security is it goes with them wherever they are moving. You're moving on-prem to the cloud, from one cloud to another cloud. You want to make sure that security is carrying with them. Those agents, those tools are with them, and they're monitoring 24/7. And lastly, change management. Like what happens if there is a change in the cloud? If you're using infrastructure as code, then that change will be captured. It can be audited. If you're just provisioning things helter-skelter within the console, it's a very good way to get compromised because you won't know what's happening. And you need to make sure those controls are there. So that was infrastructure security. What else is there? Data protection. So very, very important when you're putting things into the cloud and you don't control your infrastructure. You want to make sure your data is protected, right? What sort of keys are you going to be using? You're going to be using encryption and key management, right? Do you need hardware security modules? Because you're going to be moving to the cloud, it becomes a managed service like KMS. Okay, who will do that? Who is going to be managing? Like what sort of data leakage controls are there? I'm going to talk about cloud access brokers later on. We're going to discover that. How will you know if there is like a cardholder data within your S3 buckets or within your servers? Who's going to be monitoring that? And data residency. Which regions are you going to use? Are you even allowed to put data into one region? What happens if somebody copies data from one region to another region? Like one data center to another data center. Usually within the cloud, it's literally like pressing a button and you can change your region, right? Do you have like a customer's agreement to do that? So those are the things you need to understand when you're looking at it from the cloud perspective. Logging and monitoring within the cloud, you're going to be having millions and millions of events which are happening, okay, across one or multiple cloud environments. Even within one environment like Azure, you can have multiple subscriptions, or within AWS, multiple accounts, right? How are you going to be collating the logs? Are you going to be pumping all the clouds and logs into a single location, and from there your SIEM is going to be capturing it? So what's the model for that? We can have millions and millions of events happening, guys. What sort of logging will be happening? Application or service or OS or API? Are you going to be storing the logs on-prem, on cloud? How long are you going to retain them? All of those things you need to formalize. Don't don't be looking at this after 1 year and then you suddenly realize your logs have become like 5 terabytes and there's a lot of cost happening. So you're just helter skelter deleting logs. Don't do it like that. Have a proper strategy in place. Okay, incident response. So with incident response, we're talking about how the cloud can respond to incident, how you can really revamp your security response model in the cloud. DDoS controls, usually a lot of cloud providers, they automatically provide you vanilla DDoS controls. Some level of protection is always there because it's a public cloud, but you should subscribe to more services to make sure they are more protected, okay? Apart from that, threat intelligence. The cloud, usually they give you native feeds. You can subscribe to third-party feeds also to make sure that you get the full and all the attentions are there, okay? But please make sure that you have those things there and you can respond to them. Auto remediation is the most important thing. Auto remediation basically means that when something happens, don't wait for an alert to come and then an email to come. Within the cloud, you can actually put an auto remediation, which is like it'll automatically fix by itself. What if somebody opens an RDP port out to the internet? Don't wait for an alert to come to your SOC team and then you're running around. No, actually, you can put in controls which can automatically shut that port down. So by the time the email comes to you, you would have fixed it, okay? And lastly, like how are you going to be doing it? Are you going to be using some cloud native technology or third party? I usually recommend using a native controls because they are the fastest and they are optimized for the cloud. Okay, so take a look at that. Uh, Always do a full analysis of how you can optimize your stuff for the cloud. And lastly, of course, and this is the biggest topic, application security. As I've mentioned before, cloud is pretty much software, right? There's barely anything like hardware there. So everything is an application. Traditional security, you cannot just copy paste to things like containers or serverless, but you need to secure them, right? So you need to make sure that you have appropriate application level controls because these applications, they can become very, very dangerous entry points for things like SQL injection, automated attack. Application security is a critical part of cloud security, and you need to make sure those controls are there. Like sometimes the containers, if you know what containers are, basically it's a way of packaging your software along with its dependencies so that it can run in any environment. Whether it's running in Azure, on-prem, Google, it'll run the same because you've packaged it into a container. But container make use of images, okay? And those are copied from the internet. You can download malicious or vulnerable images that are uploaded to public libraries such as Docker. Do you have controls for that? Do you scan that? When containers are running, do you scan the security of that? Similarly, API. The whole cloud is an API security thing, right? You want to make sure that controls are there to make sure malicious API calls are stopped. Apart from that, serverless. Serverless is basically there's no hardware, there's nothing there, just code you can run on the internet, and you will be charged based on the computing power, computing time that goes. Do you have controls which can scan your serverless functions? Similarly, orchestration like Kubernetes, if there, Kubernetes, it's like built on multiple layers and what you call, you have nodes running. You have most people I know, they are not really fully educated about Kubernetes security, how orchestration works. And lastly, security as code. Security as code is so when your whole infrastructure is captured in code, when your whole applications are nothing but code, the whole cloud is like API call after API call. You want to capture your security controls as code also, and you can give it to your developers. Okay, guys, if you spin up a server, these are the minimum controls that have to be there, and you give them basically security as code, compliance as code. So the server, when it gets spun up, it's already certified. Sorry. So when your server spins up, it's already certified as per best practices. But is your team like qualified to do that? Do they have the skills? So all of these things, guys, these are the ones I wanted to mention. So these are the things you need to keep into account when you're thinking about cloud security. Okay, moving on to the last bit, cloud security solutions. I put it at the last because a lot of companies I've seen they make a mistake. They jump directly to a third party solution or a native cloud solution without doing the things I've discussed before. So please make sure you have a good foundation about the cloud. What are the risks? What are the tools you have to implement? What are these areas which I talked about? And then go move on to a third party solution. But these are good. These are all, I'm not knocking any of them. First of all, is the cloud security posture management. What is it? Usually it's a native or a commercial third party solution. It identifies, it audits your cloud environments. So whether you have Azure, Google, or a mixture of all of them, it'll plug into all of them. It'll make API calls, and then it'll automatically identify risks. And once it's identified, if you allow it, it can automatically remediate also. Okay, within your application which are running, the containers which are running, automatically you can get a single dashboard of your, say, your Oracle, your Azure, your AWS accounts, all the risks which are there in one beautiful dashboard. Your CISO becomes very happy. But it's not just a matter of visibility. You want to make sure they are fixed also. So best practices across the board for cloud security you can apply, whether it's hybrid, multi-cloud, container, cloud security posture management. Definitely, I would always recommend. You can have a native one. Azure gives you, AWS gives you, or you can apply a third-party one. Third-party ones, they give you better reporting and better support for multi-cloud. Okay. And the second solution, which I would definitely recommend, guys, is a cloud access security broker. Simply put, it's for data leakage. How do you know what people are doing in the cloud? If you're using like 100 SaaS applications like Dropbox, Gmail, Google Workspace, how do you know who is doing what, right? How do you know they're not copying or stuff out of your environment, right? So CAS is like a cloud access security broker. It becomes a single point which lets you monitor what the user activities are doing and how they're accessing it. So all the traffic goes to the CAS, and from there it goes to the application. So whether you're using Office 365, Salesforce, Dropbox, it becomes an extension of your on-prem data leakage prevention. It's very, very important. If you're using, if you have sensitive data like cardholder data, and you are adopting cloud and you want to mitigate that risk, it will give you visibility. So for example, if I try to download like cardholder data to my personal laptop from home, the CAS will kick in and it will stop it. Or if I try to upload malicious data, like a virus, to your Office 365, right? The CAS will detect it and stop it. And it'll give you an alert. It'll tell you where the events are happening. It's a very, very powerful tool, provided you implement it properly. So the CSPM, which I talked about, in the CAS, I think they are an essential component on any proper cloud strategy. So guys, this was the last part. So this basically, I've covered the solutions part one. I hope this was useful to you and you understand like how cloud security works, how cloud computing works, and you're in a better position than before. Where do you go from here? I would recommend looking at my video on cloud security risks, okay, where I talked about what are the big risks there now, because now you have a good foundation. And another one, if you're serious about certifications, there is another video on cloud security certifications also. If you found this course to be useful, one thing I would recommend is take a look at my other courses which are there on Gumroad. I put my course library on Gumroad where I regularly upload my courses. So take a look at that. I have thing on AWS, Absolute Beginners. Okay. I believe I have one on artificial intelligence also, machine learning, artificial intelligence security. I just uploaded one on the PCI DSS. So take a look. And if you want any discount codes, just reach out to me. I'm happy to give you. So guys, that's pretty much it. Thank you very much for listening to me for almost an hour. I hope you are in a better position now and you understand the cloud, how it works, what are the key risks. Thank you very much, and I will see you in the next video. Please do like and subscribe to this channel and share the videos as much as you can. It will really help the beneficial knowledge. I want to spread knowledge of cloud security as much as I can freely. So thank you very much, and I'll see you in the next video.